Complex fractions. Step 1, relax. They're just fractions. It's really no different than dividing two mixed numbers. We just have to work through the process and understand that variables and numbers are the same things. They're both values. So I started off with 1 1/3 divided by 2 1/4. We immediately know it's a small number divided by a big number. It'd be less than 1. I always write division as fractions. I change 1 1/3 to 4/3, improper fraction, 2 1/4 to 9/4. And I stick to one of my rules of algebra. Whatever I do to the bottom of a fraction, I must do to the top. And we must recognize 4/3 is the numerator and 9/4 is the denominator. So I multiply, and I just pick it because it makes the bottom 1. I pick 4/9, the reciprocal. And I do it to the bottom, and I do it to the top. 9/4 times 4/9 is 1. A number times its reciprocal is 1. 4/3 times 4/9 is 16/27. 16/27 over 1. We don't have to write over 1. So it's 16/27. And it is this simple with complex abstract fractions or variable fractions. So if I had 3/2 divided by 4/5, not should we, but could we say A is 3, B is 2, C is 4, D is 5? Do substitution. It's one of our rules. The answer is yes, we can. Not that we should, but we can. And it kind of leads to the process. 3/2 divided by 4/5 multiplied by the reciprocal of the denominator, 5/4 and 5/4, and that would lead to 15/8. If I write A over B over C over D, I multiply by the reciprocal, D over C, the reciprocal of this. But if I do it on the bottom, I must do it on the top. And when I do that, I get AD times BC over CD over DC, or CD over CD, which is 1. Again, a number times its reciprocal, whether it's variables or numerals, is always 1. And that leads to ADBC. And that is abstract complex fractions. So before I do the first problem here, I got this up here, A divided by B all over C. And it says C can't be 0 and B can't be 0. And the question I wrote there is why. And the answer to that why is you can never divide by 0, and fractions are division. So every time we have abstract fractions, there's an understanding that you can't be dividing by 0. Even if it's not written, we have to know that we can never divide by 0. That said, first thing I do is I want two fractions. I write AB over C over 1. And it's important to see the big fraction line so you know what's on top and what's on bottom. What's the reciprocal of C over 1? 1 over C. Multiply the bottom and the top. When it's on the denominator, you get 1 because you multiplied by the reciprocal. And on the top, you get A times 1, which is A, and B times C, which is BC. A over BC. Not a hard process, just like multiplying and dividing fractions with numerals. Again, example here on the left I'm going to work through. I got A divided by 1 over C. Well, the first thing I want to do is make A a fraction. So I write it as A over 1 divided by 1 over C. What's the reciprocal of 1 over C? C over 1. Top and bottom, they cancel. You're left with 1. On the top, you get A times C over 1, which is just AC. Now, I'm going to work this one out. I didn't do it all the way. I got A divided by X over B divided by A plus X. A sum is one thing. So couldn't I say U equals A plus X? I can. This is too much work, but we're going to do it anyway. And I can multiply by the reciprocal, U over B, U over B. If I do this, I get AU over XB. But what is U? Well, U, if I want to substitute for it, is A plus X. Well, I joke all the time, that's too much work. So what we're going to do is not do that substitution. Alright? And we're going to actually just multiply by the reciprocal. I'm going to treat A plus X like one thing by putting it in parentheses. And when I do that, B over A plus X times A plus X over B, reciprocals cancel to 1. And on the top I have a times the sum a plus x. So I'll write that. And on the bottom I just have bx. Nothing's the same top and bottom. Nothing can cancel. Sometimes students want to distribute. You can. I don't. And you don't have to. But if you do, you get this answer. A squared plus ax over the quantity b times x. So, a couple examples. You want to pause the video and try these. I'm going to work them rather fast. I got x over m over d, which I'm going to go d over 1. Multiply by the reciprocal, 1 over d, 1 over d. Bottom becomes 1, number times its reciprocal. On the top, x1 is x over md. On the other one, 1 over r divided by 1 over z. I'll multiply by the reciprocal, z over 1, and I get z over r. Now, if you make a mistake and multiply by the wrong reciprocal, don't just assume. Always mark out what you're doing. Because if you do that, you see you get 1 over r over z. Well, that doesn't work. Well, okay, then I'll multiply by z over r. And that's the same answer. Again, as long as you stay to the rules and do what you write, you won't make mistakes. Last board for the day on this issue has 3 examples. Again, I would recommend trying to pause and do these. I'm going to do them again rather quickly. The first one's is an easier one. N over a divided by b over d. Multiply by the reciprocal, d over b. And again, I want to be clear. I can write this any way I want. There's a number of ways you could write it, as long as you have n and d as a product in the top and a and b as a product in the bottom. Again, over here you have to recognize w plus c as a sum. Multiply by the reciprocal of the denominator. Again, I would stop here. Last one. And again, treat it like a sum. Doesn't matter if it's in the numerator of the bottom term. But something happens this time. Before I distribute, I look, is anything exactly the same? The y's are. And I'm left with x over x plus y. And since x plus y is a sum, you can't cancel the x. Again, our rules are the same. Fractions are division. Divisions are fractions. It doesn't matter if it's numerical or values.